Okay, get to the paperclip example, please, on page 27. This is the last day we're doing this. There is no doubt, I am going to leave no doubt that nobody is walking out of here without understanding how to figure out if it's significant or not. All right? That's why everyone's up front here. All right? All hands on deck. I'm not going to be doing any numbers or anything. I need you to be actually participating and just yelling out stuff for me today. All right? All of you, not just one or two people. All right? Go ahead. Read through right now about Max and his science fair. All right? He found some batteries, AAA and AA. Take a look at what he's doing with them. So he is saying the AA batteries are a better magnet than the AAAs. He did just what you guys did yesterday with the plants. He did a 5-number summary, did a box and whisker. There's the box and whiskers for the AA and the AAA. Take a look at the first question. Based on these box and whiskers, why is it incorrect for him to say that always the AA batteries are better magnets than the AAA? Always. Why is it incorrect for Matt to say that AA's will always collect more paper clips, just based on the box and whisker plot? Anybody want to take a stab at that before we reveal here? Why is it he's incorrect by saying that? Why? Well, let me ask you guys this. What's the max number of paper clips the AAA batteries? What's the max number of paper clips the AAA bat? About what? 39. What's the minimum for AAA? About 20. I'm sorry, for AA. What's the minimum for AA? About 24. The minimum. I think you're giving me quartile 1.
Oh, yeah.
20, right? So right there, look, right there. There's one instance where the AAA batteries had 39 paper clips, and then another instance where the AA's had 24. Right there. Is it always going to be that they collect more? No. And what would we talked about this yesterday. What would our box and whisker look like if AA always collected more? This bad boy would be way out here, clearly past the AAA. Okay? So here how we're going to answer it. Whoop, maybe. There were some AAA batteries that held more paper clips than AA. And I just showed you that. Look at the max for AAA and the minimum for AA right there. That one held more than the AA ones. Are you okay sitting here? Because I feel like I'm always blocking you. I feel that same way third period, but I don't care about that person. So actually, it's a nice girl. So, all right, ready? Read through the problem again. On average, how many more paper clips did the AA hold? On average, go ahead, reread the problem again, or find it real quick. On average, how many more paper clips did the AA one hold? 3.8. That's called our observed difference. And if this is starting to get repetitive, I'm glad. That means it's working. You're starting to understand it. The observed difference is 3.8. What we need to find, did they hold more batteries because it has more electromagnetism? How about that word? Or just by random chance? Okay, why was that 3.8 as high as it was? Was it by random chance, or they actually do hold more? So we did the simulation 100 times. Here's your dot plot. Locate 3.8 for me, please, on your dot plot. Here's how we find out if 3.8 is significant or not. .8. There it is. Now, some of us could argue, well, that's extreme outside. Some of us could argue, well, it's towards the middle. We have an argument. We don't have to argue because yesterday I gave you a test. And that test is if what percent of the samples fall outside it? 5%. So let's see what percent of the samples fall outside it. This is a pretty easy one. Count how many samples fall outside. How many? Goes pretty quick, right? 2 out of, how many simulations did we do? 100. So 2 out of the 100 are at or above 3.8, which is what percent? 2% are at or above 3.8. Is this 3.8 significant? This is where we get into trouble here. Well, let me ask you this way then. Is it by random chance that it holds more paper clips or that it's just more powerful? Is it by random chance or is it because it's more powerful? So this is where the confusion is? Yes? Okay. Everyone ready then? Okay, let's clean up this confusion before we leave today. If it's less than 5%, samples are less than 5%, which it is, it's 2%, this is statistically significant, this number. It is statistically significant, which means remember, hey, guys, take a look. All these here, all these dots happen by chance. All these dots happen by chance. Look where that 3.8 is. It's not with the rest of them. All right, it's on the outside. It's 2% on the outside. Okay, so it didn't happen by chance. So we get rid of it by chance, so that means that one battery was stronger than the other. Are we okay? Okay, so 2%. So this is telling me that only 2% of samples are at or above, and this is how we answer all of them, are at or above the observed difference, 3.8. Which is less than the 5% needed. So yes, Max can conclude it's statistically significant because it's below that 5% range. How are we doing here? Because we got a ton more to go here, but how are we doing right now? If it falls outside that 5% range, so something under 5%, it's statistically significant, which means the treatment worked. Okay, it wasn't by random chance. How are we doing? Okay, we good? All right, next up. Hey, Ava. Anybody know any Avas spelled like that? I have an Ava in my 8th period class, but she's a little AVA, but anybody? Really? AY? AVA? Yeah. I thought this was a little bit different spelling. So, okay. She designed an energy drink. How about that? And so group 1 got her energy drink. Group 2 just got some cola. They measured their reading times, how long it took them to read the same paragraph. And those are her results up there, guys. Those are her results. Okay, so again, energy drink group 1, cola group 2. Ava thinks that drinking her energy drinks makes students read faster. We're going to test if that's true or not. Okay, we're going to test if her energy drink made students read faster. First thing we need to find is our means. Difference in our means right now, our observed difference. So if you got your calculators with you, go ahead and find our observed difference. And somebody asked a great question. 3rd period is actually that girl I don't care for, but I'm just joking. She's fine. Which way do I go? Like, how do you always know it's group 1 minus group 2 minus group 1? How do I know which way to go? It all depends on how they did the simulation. Everyone see the simulation down below? It's group 1 minus group 2, so that's the way I want to do my observed difference. So 17.7 minus 19.1. What's our observed difference? Negative. Okay, 1.4. Everybody please stop. Stop right there. Stop right there. Don't go to the simulation yet, because I am going to ask you this on Friday's test. What does the negative 1.4 mean in terms of the problem? And I don't want an answer that says, oh, that's the difference in the means. Thank you for that. Thank you. But in terms of this problem, what does that negative 1.4 mean? Well, who had the faster reading time? Group 1, right? Everyone, Group 1 had the faster reading time. So what this means is, and we're not going to write it now because it's not going to ask, but on average, Group 1 read 1.4, what units are we? Seconds faster than Group 2. So that's what that 1.4 means. Is that on average, or you could say on average, Group 2 read 1.4 seconds slower. Okay, that's what that 1.4 represents. Okay, so how can we test if the energy drink works or not? We do this 232 times now. Okay, we shuffle these up, divide them out 232 times. Look at our simulation. Take a look at where negative 1.4 is. Find it. Where's negative 1.4? Our observed difference on the simulation. And you should be able to tell exactly here where it is because it looks like it goes by 0.1s. So about right there, I think. And again, we could argue, I think that's towards the majority. I think that's towards the extreme end. We could talk back and forth about it. We don't have time. I don't want to argue with you because we have a test to do it. All right, figure out if all the scores now, I've been doing at or above, but because it's on the negative side, I'm going to figure out how many scores now are below here. All right, so I'm going to figure out how many scores are at or below negative 1.4. That's what you and your group are going to do right now. Go ahead. And we'll see if we come up with around the same numbers. Are at or below that negative 1.4, our observed difference. Bless you. Welcome. What are we getting around how many scores here? I got a 25, about 25. Yeah, 25. Okay. So 25 scores are 25 out of how many? 232. Okay, 25 out of 232. That's about what percent of the scores? About 10.8%. Make sure you multiply that number in your calculator by 100 to get percent. So we got 10.8% of the scores are at or below her observed difference. Is Ava's mean reading time an unusual occurrence? Let's see how far we've come. Is her reading time, negative 1.4, an unusual occurrence? No, it is not an unusual occurrence because not an unusual occurrence, USUAL. Because, what are you going to tell me? It's not unusual because? Well, why? Why is it not unusual? Why'd you guys say no then? It's not statistically significant because it's not within the 5%, below 5%. Yes, there you go, guys. We got it. Because it is not below 5% of the samples. Or it's not statistically significant. Yeah, we got it. So what can you say about her energy drink? Go back to the lab, right? Keep working. Because they didn't read faster because of your energy drink. It was by some other way, which would have been what? What are the other ways they could have read faster? Smarter kids. Look at you, huh? Mr. Elite up here. Yeah. Smarter kids. Yep. You guys got any questions here for me? See how this is starting to work now? I'm starting to feel a little bit more confident here, slightly. How about some herbal remedies to cure your cold? Did you get a fresh cut over there, Lucas? This always looks that bad. No, a fresh cut? Homegrown or professional? You did it yourself or did somebody do it? Nice. Nice. Do you approve or was it forced on you that you had to get it cut? Have you had long? Because I can't picture you with long hair. Okay. Have you ever decided to grow it out, just be a rebel and get after it?
In fourth grade, it was terrible.
Like how long is long though in your case? Like did it start covering your ear or we got pictures? Because I would die to see a young Lucas, fourth grade Lucas, die to see what that mug looked like. So if you could find one, let me know. All right. Maybe I'll work my magic on Aspen, see what they have there. I don't see if they go back that far. All right. Okay, here we go. Good talk. Okay, we are going to see, you guys can read it. We're going to, 10 subjects. We divided them up into 2 groups of 5. One got the remedy, one got a placebo. All right, we're going to determine if this remedy worked or not. On a scale of 0 to 5, where 5 is the most severe type of cold do you think you have? All right, so go ahead. Let's find the means for the remedy and the placebo group. And we'll figure out if the remedy worked or is it just by random chance people in group A improved more. So go ahead, find your mean for group A and mean for group B. What was the mean for group A? 1.8, yep. And how about group B? 2.4. So as you can see, just by doing the means for the 10 people here, group A had less severity of cold. The people who got the remedy had less severity of cold than the placebo group. But was it because of the herbal compound or just some random chance? That's what we're going to test right now. What's the first thing I need to find? Difference in the means, my observed difference, yes. And I will tell you it's group A minus group B. I know it doesn't, it should say it down here, but group A minus group B. So find your observed difference so we can compare it to the simulation. (1.8) minus 2.4, my observed difference, negative 0.6. So now we did 300 this time. 300 shuffles, go ahead, find out where negative 0.6 is. And whether by yourself or within your group, figure out if that was by chance they improved more or actually by the herbal remedy. And we're just going to have to estimate here the people that are at or below this one. But we should all be in the same ballpark. You're not going to overestimate it that much where it's going to affect the answer. What are we getting? About how many are at or below? I said 35, 34, 33. What did you get, Brianne? Something way off? What'd you get? I think that still would be okay, though. I don't think you'd throw it off that much. So, yeah, that's fine. We'll go with the 35. Out of how many simulations did we do here, guys? 300, right? So 35 out of 300. That'll be about 11.7%. Everyone checking my math here? About 11.7% are at or below. Why did the people in Group A improve more? By the remedy or by chance? Chance, because, ready? Here we go. Let's start talking a little vocab. Is negative 0.06 statistically significant? No, it is not, because it fell above our 5% range. Okay, so again, let's just put it all together here. So 11.7% of samples are at or below the observed difference making it statistically significant. Making it not statistically significant. So this herbal compound, no good. Okay, what are some factors that they got better? They took something else. They rested. Any other thoughts? Hydrated. Nice and hydrated. Not just hydrated, nice and hydrated. I don't know what makes you nice and hydrated. Guys, got any questions? How we starting to pick this up a little bit now? Okay, I think we got 2 more to do here together. Yep. I just like reading the scenarios. Go right ahead. Now we got tutors versus an online tutorial. Which one led to better test grades? Okay. All right. Group 1 met with the tutor twice a week. Group 2 did the online tutorial twice a week. There are the mean test scores. So it looks like the tutorial people did better, right? Or was it because it was the tutorial or just by random chance? Let's find out. Did the tutorial actually do much better than the tutor or not? Calculate the mean difference. Go ahead, the mean difference. Group 1 minus group 2. Remember, we're using X bar here. We're not using the sample, standard deviation. So group 1 mean difference negative 3.64. And I do ask it in this case, and I'm going to say, what does that negative 3.64 mean as far as the problem goes? And again, I don't want difference in the means to be the answer. As far as the problem goes, what does that negative 3.64 mean? Well, let's start this off. On average, tell me something. On average, hello, I almost did it. Megan? So I wouldn't say times, though. I'd probably say percent. Okay, so on average, group 1 scored 3.64% lower than group 2. See, now it's all in my mind now because that's exactly where your sister sits last period. So not that anybody cares. Good story, I know. Was it because of the online tutorial that these people scored 3.64% higher? Was it because of the tutorial or just by random chance? Let's figure it out. We go to the simulation, figure out where negative 3.64 is, please. Find where negative 3.64 is. Estimate it. Was it because of the tutorial we had the change or some other random chance? What are we getting about? How many scores here? This could be a little bit different for everybody. I got 8. That was one off from what I put 9. Anybody 10, 11, 12? I don't think you're going to throw it off that much unless you get into like the 20s or the 30s. What do we want to go with, Vinny? 8? We'll go say 8. 8 out of how many, Vinny? How many times we do this simulation? 500. Somebody's got some time. Which is about 1.6%. Significant difference in the final grades? Yeah, why? Because this is way below our threshold of 5%. Yep. So 1.6 of samples are at or below. We know this deal. At or below the observed difference. It's the same writing every time. Resulting in significant difference in final grades. Who would have thought online tutorial made the difference? Significant difference in final grades. I think that's still baloney, but that's what the numbers tell us. Everyone doing all right? Big plans tonight? Yep. My boy's got plans. He's coming out ready to party. All right, back to tomato plants. 10 tomatoes here. Anybody? Maters? No? Short for tomatoes. Thank you, Lucas. Thank you. Thank you. Anybody despise tomatoes? You do? Seriously, you do? Like salad, nothing in your salad, nothing like on a burger, toppings wise. Sandwich, nothing. Okay. Anybody else? Always got to put it in the tossed salad. Cucumbers, lettuce, croutons. That's about as far as I go. I don't get more exotic than that. Anybody else in their salad? My wife puts cranberries, and I can't understand. Like that's just something sweet and something that it's not supposed to be sweet, but whatever. Anybody else throw in their tossed salad? Veggies or peppers or radishes, onions. I think have I made my feelings felt about onions in here? On nothing. Nothing. Awful. No one wants to contribute to the tossed salad stuff. Okay. I much rather would have a Caesar salad though than a tossed salad, if you're wondering. Any day. Why do you make it so awkward? Trying to have some conversation and nobody's like wants to chime in here. This is awful. As awkward as possible. I'm just giving you my soul out to everything, and then you guys come back with nothing. I'm sure you do. All right. How about you find me that Lucas 4th grade? Maybe I'll find you, if I can, I don't know, it's going to be hard to find, but maybe a John Carlino 4th grade. All right, we'll put those side by side. Okay. It might. I was a little chunker back in the day, Vinny. I'm not going to lie. All right, little chunker back in the day. All right, I had a full head of hair too. Yeah. I'm not going to be proud. All right. Because I'm sure it's one of those with like a striped shirt and some lasers going from behind, like all those backgrounds you could get. Yeah, I always went with the most exotic ones. All right, let's finish this up. We got 10 tomatoes, randomly put them into 2 groups of 5. Group A got nutrients, Group B did not. It just got water and sunlight. So did those nutrients contribute to a bigger growth in A? So what I need you guys to do right now, A, B, and C, go ahead. That's a 9.1, not an 8.1. All right, 9.1. So calculate the mean weights for Group A and the mean weights for Group B, and then the difference. What'd you guys get? Mean weight of Group A's tomatoes, 6.76. Group B tomatoes should have been 6.48. The difference in the means of Group A minus Group B should have been 0.28. Yep. And just let me quiz you on this right now. What's that 0.28 mean as far as the problem goes? On average, what? Group A's tomatoes weighed 0.28. I'm going to assume ounces. I don't think it's pounds because that's a 9-pound tomato right there. All right, about 0.28 ounces more than Group B. Is it because of the treatment, though? Is it because of the nutrients we gave it? Look down at the simulation, and I picked this one, and I saved it for last for a reason, because sometimes, take a look where 0.28 would be, about right there. Sometimes it's pretty obvious. You don't need to count to see if it's 5% or not. Does everyone see this is pretty much in the majority around where all the other random chance ones are? So in this case, I'm not expecting you to go, holy jeez, is that 2 dots to connected? Is that 1, 2, 3? You don't have to do that. Obviously, it's within the majority. Right here, it's not on the extreme outside. It's within the majority. I don't think we can argue that it's on the extreme, right? No one's going to take that side of the argument. Okay, so we could say, is there significant difference in the treated tomatoes? Well, no. It fell right with the majority of them, so there's no. Because the observed difference, and we shouldn't mention anything about 5% because we didn't do it here, because the observed difference is within the majority of the samples. Okay, it's not unusual. It's by chance that they grew a little bit bigger than B. We feel more confident here. Inside the 95% confidence, never mind. I'm not going to make math jokes. Everyone good? Questions? Comments? All right, there's no assignment tonight. Friday's the test. We got one more little topic tomorrow, and then that's it for the course. Well, the Algebra 2 part of it anyway. Nice job, everybody.